nature, nature gave water, and God created humankind, and humankind converted the power of water to energy. Garo Hills region of Meghalaya has rich resources, and to tap the potential of hydropower, the Meghalaya Energy Corporation Limited or MECL conceptualized the most ambitious and prestigious project, the 22.5 megawatt Ganol hydropower project. It is the first hydropower station in Garo Hills and will be etched in the history of Meghalaya as an engineering marvel.
The letter of award for construction of 3 into 7.5 megawatt Ganol small hydro project was awarded to Mesa Patel Engineering Limited in the year 2014. The project consists of concrete gravity dam of height 35 meter with a HRT tunnel of 1.9 kilometer and high pressure tunnel of 700 meter. It also consists of a short shaft of 47 meter height with a diameter of 8 meter. In the powerhouse we have 3 number of 7.5 megawatt turbine generator which was supplied by Toshiba India Private Limited.
Let us know more about the project. Ganol River originates from Tura Peak in West Garo Hills. It travels through 49.14 kilometers and joins the Brahmaputra River near Mankachar town on Bangladesh border. The fall of the Ganol River between village Chibragre and Edenbari is used to create a power head of 152 meters. The Ganol Hydroelectric Project was envisaged by Meghalaya Power Generation Corporation Limited by utilizing the Ganol River Fall and its water by installing 3 turbine generator units of 7.5 megawatt each. Hence, the project would generate 22.5 megawatts of power. Meghalaya Power Generation Corporation, along with different stakeholders, including India's leading hydropower construction company, Patel Engineering Limited, Mumbai, as its lead contractor, and civil and HM contractor, Onicon Infra LLP Mumbai, and E&M contractor, Toshiba Plant Systems and Services Corporation, Japan, combined together to complete the first engineering marvel hydropower project of Garo Hills. Ganol Hydro Project is unique, having maximum features of hydro projects, that is, the diversion tunnel, dam, power intake, head raise tunnel, surge shaft, upper horizontal, vertical and lower horizontal pressure shafts. Finally, the powerhouse along with switch yard. To construct the dam, Ganol River was firstly diverted into a tunnel by boring a diversion tunnel of 133 meters long at a level below the flow of river, and a coffer dam was constructed to block the seepages, thus minimizing the water at the dam axis. The concrete gravity dam, located at 20 kilometers distance from originating point of Ganol River, is having a length of 100 meters and a height of 34 meters. The dam has 3 overflow blocks equipped with radial gate of 7.5 meters width and 8 meter in height, through which reservoir water is to be regulated during floods. The geology and location made the construction of dam an extreme challenge. Engineers of MEPGCL, Patel Engineering and Onicon handled this unfavorable shear zones at the foundation of the dam successfully.
Onicon Infra LLP is executing several infra projects all over India. We are responsible for execution of Ganol Hydro project also, for which we are thankful to Patel Engineering and MEPGCL also. We have done complete work of hydro civil works as well HM works of this project. The dam, which was a very challenging one because of the foundation problems. We have done 35 meter in height and 100 meter in length.
Initially, when we open up all the work fronts of the project, the half of the project is having a very good geology and the other half is in a very bad geology. So to do the tunneling work, it was really a challenging task for each and every one of us.
The water to be carried to powerhouse requires a water entry structure in the reservoir. The power intake structure, constructed with a height of 20 meters in reinforced cement concrete on the left bank of the river near dam, is equipped with a regulatory gate of size 3.87 meters wide and 3.4 meters high. One cannot achieve the aim without a carrier, and therefore a water carrier tunnel from intake, known as head raise tunnel in technical terms, is pierced through the rock. In a length of 1.984 kilometers, the tunnel boring was done through a very weak strata in a length of about 700 meters. This was tackled by providing strong steel supports and reinforced cement concrete lining by the professional tunneling team of Onicon. Dealing with mighty power of water is not simple. While operating the turbine units, the operation team has to face the fluctuation of water flow in the water conductor system like head raise tunnel, pressure shafts. To absorb the fluctuation in flow and its effects, a 9.5 meter diameter vertical surge shaft of 40 meters in height was bored below the ground, which was then lined with concrete on periphery by team MEPGCL, Patel Engineering and Onicon Infra workforce. The vertical pressure shaft's excavation met with challenges of tackling weak rock and heavy seepage. The excavation, thus, was difficult. With innovative ideas of creating steel umbrella to avoid falling of rock and seepage water on workers, drill and blast was carried out. The seepage water was allowed to percolate through a peripheral curtain to down below level, wherefrom it was pumped to let out at top. Water finally reaches the turbines in the powerhouse. It rotates, it sounds, it converts kinetic energy into electrical energy. It is powerful turbine generator. Ganol Hydro Project has 3 such numbers each of 7.5 megawatt power. Earlier it was a tree house at this location. Now it is a powerhouse. Each turbine in powerhouse works at 152 meters of water head.
The project itself comprises of 3 components, mainly civil work 65%, then 20% electromechanical work and 15% hydromechanical works. This project will benefit the state as a whole, particularly the Garo Hills region.
MEPGCL, Patel Engineering, Onicon Infra and Toshiba Plant Systems and Services Corporation, Japan create a history in Garo Hills by the installation of 1 unit in powerhouse and generating 11 kVA.
We TPSA India are happy to announce that we have installed vertical Francis unit in Tura, West Garo Hills, district of Meghalaya, with the support of Government of Meghalaya, MEPGCL, Patel Engineering and local people. The turbines are designed with proven Japanese technology, which is incorporated in the existing product.
Toshiba is also the supplier and installer of the turbines and generators. The 22.5 megawatt power will generate an average annual energy of 74.06 gigawatts. Congratulations Garo Hills, taking Meghalaya forward, development first.
These projects will cater to the needs of Garo Hills, in particular Tura region. It has a peak capacity of 22.5 megawatt and during lean seasons it will be a great help to Garo Hills.
We at Patel Engineering consider ourselves extremely fortunate on being associated with MECL and the government of Meghalaya in establishing the very first hydro project in Garo Hills. We take extreme pride in bringing our more than 50 years of experience in dams and tunneling to the construction of this high-tech structure, which is literally an engineering marvel in the state of Meghalaya. We thank Ornicon Infra and TPSC in bringing this project to a grand success. As a matter of fact, we are looking at starting the Unit 3 this week. So, wishing everybody all the best.